Hello again, everyone. Welcome back to CPCS203, Programming 2. Um, Today I'm going to wrap up this set of slides. Definitely tried to last time, but the last topic took a little too long. I'm going to cover a bunch of stuff today. I'm but going to give you a programming example of only one of those. You can work out the other one. So the first thing I'm going to talk about is a class that comes with Java in the java.util library called ArrayList. Now, an array list is a data structure. I know many of you, most of you probably haven't taken the data structures course yet. So I'm giving you a brief introduction of what a data structure is. Um, so you can think of the arrays that we have used so far as the first data structure up from single variables. So you remember that when we declare and create an array, we have to declare at that time. We have to decide at that time what the size of that array is going to be. And once it's created, you cannot change the size of the array. You can change the elements that you put into the array, but not the size of the array. Now that might not be convenient for every situation, and for such a situation, we have an alternative data structure called a linked list. And this picture over here is basically showing what a linked list looks like. Now, first of all, the advantage of a linked list over an array, that's kind of what we should compare this to, is that the size of a linked list will grow and shrink to any size that you need, as long as you have enough memory in on your computer. Whereas, again, size of an array remains fixed. And you can insert or remove elements at any place in that linked list. So you can think of a linked list as a chain of elements. So over here, for example, we have I'm showing an array, a linked list made using the Java util ArrayList class. Its first element, so this arrow over here points to the first element in the array list. We also call that the head of the linked list, and it stores an integer 10. Um, After that, attached to it is a reference, basically the address to where in your memory the next element is located. The next element is somewhere else in memory, and it stores the integer 55. And the next element stores the integer 5, then the integer 1, the next one the number 34, the next one 66, and then we get to the last. This is the last element of this linked list, which we also call the tail end of a linked list. Now, you can insert and remove any of these elements from any place at any time. The disadvantage of a linked list is that it is slower than an array. So you cannot jump to just directly to any element. So let's say if you want to go to the fifth element over here in your linked list. In a linked list, what you do is you always only have the reference to the head element, the first element, which means you go to the first element, then you start counting. You go to the second, third, the fourth, and then the fifth element, and then once you're there, then you can perform whatever operation you need to. Now, fortunately, you don't have to think about any of that. You should, however, know what a linked list looks like in the memory of your system. So the ArrayList class of Java manages all of this for you. So just to give you an idea, if you want to insert a new element into a linked list, this is basically what happens. The ArrayList class will allocate a new piece of memory for a new node. Each of these elements is also called a chain, a link, or an element of the array list. It allocates memory for a new element, and then it changes the reference of, let's say we want to insert it at the fourth position in the array list, in the linked list. It will change the, where these references, or in other words, where these pointers are pointing at, and you end up with this new linked list containing 7 elements: first, second, third, fourth, fifth, sixth, seventh. And just like that, it's also very easy to remove an element. In that case, you deallocate the, first of all, actually, um, you redirect the link from the second to the fourth element and deallocate the memory you have allocated to the third element. And that is how you delete or remove an element from an array list. Again, you don't have to do any of these steps yourself when you're using Java's ArrayList class. However, when you will study, or when you take data structures, you will be expected to build uh, basically a class of your own that does exactly what the ArrayList class does for you. And then you'll really get into this, how you connect from one node to another and what the steps for that are. Meanwhile, this is the UML class diagram for the ArrayList class in Java. Um, another class called Vector should also take a look at. Here's a bunch of methods that the ArrayList class comes with. Um, so let's so obviously there's a constructor, array list, same thing, add, if you want to add a new object to your list. Uh, point to note is that the argument to the add method is of type object, which means now that we know about polymorphism, you can create an array list of any type of, of class or objects or primitive data members. So you can make an array list or linked list of strings, of integers, of double numbers, of long integers, or of any other type of class that you have. Anything that is a subclass or a sub-subclass of the object class, which is all of them. Um, there's also another add method in which you can provide or specify the location at which you want your new object inserted into the linked list. Clear removes all elements from the list, so that's kind of like a reset. Contains returns true if the list contains whatever object you provided over here. So it's basically check whether a certain element is already in the list. Get gets you the location, gets you the element from a specific location. So you can provide an integer over here, want the 0th element, the first element, the second element, third element, and so on. Index of, you can provide an object, and this will give you the location of the first matching element. If you have multiple elements that match the object you give over here, you'll get only the location of the first one. Last index addresses that and gives you the location of the last occurrence of whatever object you give it over here. Is empty is a method that tells you whether or not your list contains any elements or not. Size tells you how many elements you already have in the list. Remove is basically the reverse of the add method, lets you remove an element from the location you give it in the argument. Yeah, and set can be used, sets the element at a specific index, so you can change the object at a certain location, or change the location of an element. Okay, all right. So here's here's an example that I'll do for you now. Okay. So what I'll do, so this example is also given in slides, but I'll just show you to make sure that, so we're going to make an array list called city list, java.util.ArrayList, and this is going to be called to the constructor. Okay, so you can see we create this object of type array list the same way we create any other object. Okay, so I'm going to keep a list of city names. This, so I'm going to use, first of all, I'm going to add city list. Yeah, I'm going to add first element, and the first element is going to be London. Okay. Um, let's say let's add a couple of city names. So city list. Sorry, city list dot add, and then I'm going to add, follow the example that we have, Denver, and then I'm going to add Paris. I'm going to add Miami, and let's go east, Seoul, and stay east, Tokyo. Okay, so now we have got a decent list. Okay, uh, so let me add some comments over here. Um, so after I do this, the list will basically contain only London. When I do the second call to the add method, the list will contain London, followed by Denver. So this is just so you can follow along what's happening in the background. And then we added Paris, and then Paris will go to the end of that list again. And I'm going to save myself some typing. After Paris, we added Miami, and then after Miami, we added Seoul. So this is what the list is going to look like. And finally, we added Tokyo. So this is what the list looks like at the moment. Okay, so let's try out some of the other methods. So system out print line, and so list size. Print out how many elements I have in there, and so list size. I'm going to print out city list dot size, and that's going to give us the number of elements we have in there. And let's say I want to, let's try the contains method system print line again, and so I'm basically checking is Miami in the list, and answer should be true or false. So I'm going to call city list dot, and I'm going to use the contains method. I want to check for Miami. Okay, let's run this so far. So list size is 6. We have 6 elements, and then Miami is in the list. True. Yes, it is, because we added it in 4th location. Okay. Let's see what else. Let's check for the location of a particular element. So the location of Denver in the list, question mark, city list dot, let's see, finally what it's supposed to, index of. I want to know the location of Denver. Sensitive, I guess. If I run this, see, Denver was added in 2nd place. Okay. Location 1. Remember, counting starts at 0. Okay, so 0, 1. Location 1. That's the 2nd position. Okay. Okay, what else? Oh yeah, let's try another method. Oops, system not. What happened there? System.out dot is the list empty? Question mark. And city list dot. So that we're going to call the is empty method. If it's empty, return value will be true. See, but it's not, so the answer is false because we have 6 elements in there. Okay. What else? Okay, so let's do insertion. Um, so city list dot add. So let's use the add method, but this time let's add not just anywhere. Let's add a city not at the end, but somewhere in the middle. So at location 2. Okay. And when we do that, this list will then be in a state, so this is location 0, this is location 1, and if I introduce Xi'an over here, then these other cities will move 1 count ahead. Okay. Okay. And if you're curious to see if that actually happened, put in a for loop. Let's just print out what we have so far. Let's make that. I'm going to use this loop a couple of times. So let me just put this up here. Let's declare all objects and variables up there. Okay, so for I 0, I less than. So this loop should run for as long as we have number of, or the now equal to the number of elements that we have in the city list. System dot out dot print line, and going to call city list dot get method, get element I from the list, and put a space in between. Just a space is fine, I guess. And we're done. Line. Let's just put a new line character, and this will look nice and neat. Let's make this even more fancy. There you go. So I'm going to put all of these in square bracket. Let me run this once. So this loop over here will print out all the cities in the list. So basically we should see a list like this one that we have in the comments. Xi'an in second place. Okay, hold on. So it should not be print line. It should just be print without the new line inserted. There you go. London, Denver, Xi'an in location 2, followed by Paris, Miami, Seoul, Tokyo. Just what we wanted. Okay. So actually we can rerun this anytime. Just copy paste this anytime. Wherever you want to see the status situation of this list. So let's also try out the remove method. So let's say we want to remove Miami from the list. We can do that, which will print out everything after that. So this should remove Miami from over here, and this is what we expect to see. Let's see if that happens. There you go. London, Denver, Xi'an, Paris. Miami is gone, and Seoul and Tokyo are still left. Okay, and let's also um, call the city list to string method to see what that gives us. Mhm. And so London, Denver, Xi'an. So you can see that the thing that we're doing using this loop, if you call the toString method for an array list, it basically does that nice formatting for you. Even inserts those commas, so slightly nicer formatted than what we did, and without this annoying blank space after the last element. Okay. All right. Um, what else? Mm, so yes, so this was this is the city list, linked list, or array list was one that stored elements that were of type string. Um, let me demonstrate an array list. Let's call this one list, or actually geolist. Uh, a list that a list of objects, not just primitive data types. So make a new list, and as you can see, I already added the geometric object and circle classes that we used previously. I already added those to our project over here. So we really don't care what the code is in here. I just took these two classes from previous weeks, and I added them to, copied and added them to our project over here. And now I'm just going to do list dot add, and oh sorry, it's geolist. I'm sorry, calling this geolist for geometric object list. I'm going to call the add method, and I'm going to add a new circle object over here, and circle with a radius 2. Okay, and let me also add another circle with a radius of 3. And let's say I now want to access I want to call a method of any of these circles over here, so I can do that. System dot out dot println okay, so let me call the get area method. That should work, right? The area of the circle, and going to, oh yeah, that's actually something new you should see over here. Okay, let me show you. So geolist dot get, and let's say I want to call get area for the first element I have in here. Now this will just get me the object. Then I want to call the get area method on that. Okay. Now this is looking weird. So what we have to do is we have to put parentheses around here, so that all of this will retrieve or access one of the circle objects in GeoList, the first one. Now, this won't work as it is. Let me run this and show you. We'll get an error on this. Okay, there you go. So one thing we have to do over here is that we have to cast the object that we're getting back from this get method. We have to cast that. We have to tell the compiler what that actually is. Now we know that it is an object of type circle, so this is how we do casting, remember. So we have to insert, we have to cast the object as a circle, and then we can call the get method. We run this again, this should work. There you go. The area of the circle, 12.5666, and so on. And just like that, you could also do this for the second circle that you added to the geo list. Like this. Area of the circle, 28.27, and so on. Finally, if you are curious about what the toString method will look like, copy paste that. Where did we have it? Copy paste that to the geolist. So remember, geolist contains these two circle objects, and this is what you get. And as you can see, this will in turn call the toString methods of those circles that we have, of those circle objects. Okay, so that's pretty much, that should be enough to get you started on using array lists. This is largely the same example that we just did. In addition to the array list or linked list, there's another data structure you should be aware of. Again, you'll study this in detail in your data structures course. This data structure is called a stack. Okay, stack. I have the Arabic word for it over here, the comma, I think. So a stack is kind of like a linked list, but there are some restrictions on what operations you can perform. So in a linked list, we were able to insert and remove elements from absolutely any place in the list. In a stack, that is not the case. In a stack, you can add elements, but they always go on one end. So let's say, think of this as a linked list for a moment in this picture. So you start with one element over here, you add another one, you add another one, another. So all the elements go or are added to the end of the linked list. You should think of it as a linked list over here. And when you want to start removing elements, you have to remove them from the same end again, which means if you're adding and inserting elements, the last element to go in is also the first element to come out. You cannot remove elements from somewhere in the middle or from the other end of a stack. Think of a stack like a stack of plates that you have sitting in the kitchen. You stack plates one after the other, and then when you need a plate, you usually pick up the one on top, right? Now the add and remove operations in the stack, they're not called add and remove. We use two specific terms for that. When you are adding an element to a stack data structure, we call that operation a push operation. And when you're removing an element from the top of a stack data structure, we call that operation a pop operation. Now, as you can see, stack allows for fewer operations, has more restrictions than a linked list, which means you could take an array list object like this. You could put it inside a class of your own. You could call it MyStack. You can put it in there as a data member, and then you could make your own methods which really just call array lists methods. And you could have an isEmpty method, which just calls the array lists isEmpty method. You can have a getSize method, which just calls the size method of the underlying array list. You could have a peek method, which returns the top element in the stack. So just let's take a look at it, doesn't remove it. You can have a pop method, which just gives you the element at the top and removes it from the stack. You can have a push method, which adds a new element to the end. So that's basically just a call to the add method of the array list inside. And maybe a search method that lets you look up for objects in a stack. Okay, so that was all about the ArrayList class in Java, and how you can use it directly and how you can use it to make other data structures such as a stack. It's quite versatile, the ArrayList the class that we have. Okay, so let's get to two new topics. Last one is really short, so this is really the last thing that we're going to talk about. So you already saw that we have different ways of controlling, different levels of controlling uh, uh, how or where a certain member variable of a class or a method will be accessible. We can either declare private, which means no one outside the class, you cannot access that data member from anywhere outside the class, only from code or methods inside the same class. Um, or you can set to public. We saw that too. And when you set the visibility level to public, it becomes accessible to every other class. Uh, Anyone can access that data member directly, which is usually not what we do. That's bad practice. But I mentioned earlier in the course that there are not just these two visibility levels, there's actually also a default level, which is the level that is applied when you don't write anything in front of a variable. So in the beginning of the course, that's what you were actually doing. You were actually setting all the visibility level of member variables and methods. You were setting them all to default. But there's another fourth visibility level for which we use the term, the keyword protected. So today we'll learn the difference between these four levels. Um, so first thing you should remember is basically protected a protected data member um, uh, in a public class can be accessed by any class in the same package. Now, if I go back to the code that we wrote today, you'll notice that every time we made a project, the classes that we made showed up inside of this container, which represented a package. If you look at the very top of your files of any project, the first line was always package and then the name of the project basically, or a variation of that, week underscore 12 underscore 1. If you look at the circle class that I've added to the same project, you can see it says the same thing, package week 12 underscore 1. The geometric object class, week 12 underscore 1. I had to add the geometric object class. We didn't use it directly, but remember circle extends geometric object, so that's why I had to keep this class in this project as well. So you can see that I can group classes together into packages. Okay. So if I set the visibility level of a data member or a method, if I set it to protected, what happens is that any class in the same package can access that data member or method. Or, of course, any subclass that extends or is derived from your class can also access those data members or methods. Um, Sorry, jumping ahead. So the visibility level of data members and methods is least when you set it to private. It visibility increases a little bit if you set it to default, so basically if you write nothing. It increases a little further when you set it to protected, and increases to complete visibility when you set it to public. So visibility increases from private to default to protected to public. So let me explain that a little more. Um, so this is one way you can remember this. If you're good with tables, you can try remembering this table. So if you have something set to public, it can be accessed from the same class, can be accessed from the same package, any class in the same package, can be accessed from a subclass of your class, and can be accessed from different packages as well. If you set something to protected, you'll see that it cannot be accessed from classes in different packages that are not subclasses. If you set it to default, visibility goes down to same class, of course, uh, and can be accessed by classes in the same package. But even subclasses cannot access that data member or method anymore. And private, of course, as we know, reduces or limits access to data members and methods to only within the same class. Here's another way you can remember this. So over here we have basically all of these cases. You can see all of these cases at work. So we have one package, this blue one up here, which I call MT2, short for midterm 2. And we have another package down here in red called EXT. Think of it as an extension. And this is the main class that we're talking about. We have a class A1, okay? And it contains a public integer, W, a protected integer, X, an integer Y with default visibility level. You can see we have nothing, no keyword in front of that. And we have a private integer, Z, and just for fun, I added another method with protected visibility level. Visibility level for this method M will be the same as for the protected integer X, because they're both protected. Okay, and besides that, we have in the same package MT2, we have a class A2, which is a subclass of A1. You see that because of this arrow over here. And we have another class, A3, which is not a subclass of A1. So this is a class that's in the same package as A1, but it's not inheriting anything from A1. It's not its subclass or superclass. No relationship. Then we have in the second package EXT, we have two classes. One is class A4, which, as you can see, is a subclass of A1. And then in class A5, also in the other package EXT, this does not have any relationship with A1. It's not a subclass. Okay. So let's go element by element. So for the integer W that's been declared public in A1, because it's public, we said something that's easy to remember. This will be visible to everyone, whether the other class is a subclass of A1 or not, whether the class is in the same package or not in the same package. As you can see, it says here, so can access a.wa is an instance of class A1. So the W is accessible from A2, from A3, which is just in the same package as A1. It is accessible from A4, which is a subclass in a different package, and it is also accessible from A5, which is a class in a different package, no relationship. Then we have protected integer X, and this is accessible to all classes in the same package, subclasses and not subclasses. It is also accessible from subclasses in other packages, but it is not accessible to classes in other packages that have no relationship, that are not subclasses of A1. So that's why this is in red. Figure that out. Okay, let's look at at integer Y, which has visibility level default, and you can see that this reduces the visibility. Now, the subclass A4 cannot access Y anymore. Why? Because it's in a different package. Classes A2 and A3 can continue to access Y because they're in the same package as A1. Then we have private integer Z, and that's also easy to remember. This will not be accessible or visible to any class outside of A1. Okay. You can access Z only from inside class A1. It's red everywhere. And then, just for repetition, we had this method M, set visibility is set to protected, and its visibility is the same as that of integer x, which is also set to protected. Again, repetition, it is accessible to all classes in the same package and all subclasses in other packages. Okay. All right. One other principle, one other thing to remember, um, a subclass cannot reduce the visibility or accessibility of a member variable or method. Okay? Cannot reduce the visibility. Increase it, sure, but not decrease it. Okay. Last topic, it's very easy, very short, is another modifier called set, which is final. Um, Now you can set a class final, so like this, final class is math, for example. What that does is that it prevents you from making any subclass of this class. So in the tree of classes, if you make one of the classes final, if you set it final, means you're not allowed to make any subclasses of this class anymore. If you set a variable to final, it becomes a constant. Its value is not allowed to change. Remember when we used pi, math.pi? Pi is a final static double variable. So the value of pi, of course, does not change. It's a constant in mathematics. So um, it is in the math library. It is set to final. And methods can also be declared final. What that does is final method cannot be overridden by its subclasses. So basically, if a method is declared final, you have to use that method as it is. You cannot override it. Okay. This is different from static methods. Figure out what the difference. Look up what the difference was. Okay. I'll give you a hint. You should know the difference in order to answer at least one question on our second midterm exam. Okay? Figure out the difference between setting a method to final and setting a method, putting the static keyword in front of a method. Okay, so that's it for today, and next time we'll begin with the next set of lecture slides. See you next class.